Hi, logic students. I'm making this video for you about section 1.3. This is the section about the distinction between deductive and inductive arguments. This is an important distinction. I think at some level you can understand it intuitively without really much need for explanation. So maybe the best way is to start with two examples, which just by comparing one example of a deductive argument and one of an inductive argument. When you make a deductive argument, you make it with the understanding that the conclusion follows necessarily from the premises. So if you look at the argument here on the left-hand side, if you suppose that A, B, and C are three numbers, and A is greater than B, B is greater than C, it follows necessarily that A is greater than C. When you're putting forward that conclusion, you're not putting it forward in the spirit of saying that maybe, possibly, probably A is greater than C. Well, no, it follows necessarily from the premises that A is greater than C. So when you make an argument with the understanding that the conclusion follows necessarily from the premises, then you're making a deductive argument. Compare this with the other example here. If you know that 75% of high school students in the US eat French fries at least once a week, and Albert is a high school student in the US, it's probable that Albert eats French fries at least once a week. The information that you have in the premises warrants the conclusion that probably this particular person has French fries at least once a week. However, it's not certain, and you don't put forward the argument with the understanding that it's certain that Albert eats French fries at least once a week. You know that there's a margin of error. Maybe Albert has some kind of food allergy, or maybe he doesn't like French fries, and certainly that would in some sense defeat the conclusion in his particular case. He wouldn't be one of the people who eat French fries at least once a week. Notice that there's a tip-off in this argument, the word probably, that obviously indicates that whoever is putting forward this argument is doing so with the understanding that the conclusion only follows probably from the premises. But notice that if we removed the word, the argument would still be inductive. It's not really that, even if somebody were to say, therefore, it's absolutely certain that Albert eats French fries at least once a week. Still, if you're honest about this argument, you have to see that it's not absolutely certain that Albert eats French fries at least once a week. So the nature of the inference here is that the premises, if you're really honest about this, the premises only support the conclusion to an extent. They make it likely, they make it probable. So even if you were to rephrase the conclusion, so as to say it's absolutely certain that Albert eats French fries at least once a week, the argument would still be inductive, not deductive. Okay, so I think it's at this point it should be fairly clear how to distinguish between these two types of arguments. You look at the strength of the inference. Here the inference is meant to be extremely strong. The conclusion is put forward, the understanding that it follows necessarily from the premises. Whereas here the conclusion is put forward as being probable or likely. In the first case, you have a deductive argument. In this other case, on the right-hand side, you have an inductive argument. You also pay attention to the wording, so if there's the word probably, more often than not, that is an indication that the argument is inductive. Similarly, if you find wording in an argument that is deductive, that points to the idea that the conclusion follows necessarily from the premises. But like I said, the most important thing is the strength of the inference, of the conclusion that is being drawn. Our textbook is also very good about classifying types of deductive and inductive arguments. There are types of arguments that fall into um, one or the other category. So if you're familiar with those types of arguments, then you will know automatically whether the argument is deductive or inductive. You can review this in the textbook. I'm not going to go over every single type of argument here because it's covered, these arguments are covered extensively in the textbook. But mathematical reasoning is deductive, arguments from definition, syllogisms, either categorical, hypothetical, or disjunctive. These are all types of deductive arguments. So you have to be familiar with those types of arguments. Whereas inductive reasoning is about establishing the conclusion with a certain degree of probability, like we said. So when you make predictions based on the information that you have, you're reasoning inductively. When you're using analogies, when you're saying that two things are similar, so what is true of the first is probably true of the second as well. That's an inductive argument. When you generalize, you have a few cases of a certain sort, and you generalize that all cases of that kind will display a certain feature and whatnot. That is inductive reasoning. When you're relying on somebody's knowledge, expertise, or authority, it's an inductive argument. Even the most experienced person may go wrong. So if you rely on an authority, you only establish the conclusion with some degree of probability, not with certainty. Arguments based on science, on information that is posted somewhere, are inductive, and also causal inferences when you're reasoning about cause and effect. When you're seeing some clues, for example, and you infer that the cause of the clues that you observe must be so and so, then you're reasoning inductively. You don't have the absolute certainty that the conclusion follows from the premises. Let's look at a few examples from the textbook, and we can see how to apply all this. I just wanted to show you a couple or maybe 4 examples overall from the textbook. What about this one, number 10? The Encyclopedia Britannica has an article on symbiosis. The Encyclopedia Americana, like the Britannica, is an excellent reference work. Therefore, the Americana probably also has an article on symbiosis. So here you should be able to see that it's an inductive argument. The word probably certainly gives it away, but also, and more importantly, this is an argument from analogy. The idea is that there are two things, the Encyclopedia Britannica and the Encyclopedia Americana. They're similar to each other. So if the Encyclopedia Britannica has a certain article, you can reasonably expect the Encyclopedia Americana to have the same or an article on the same topic. Okay, so you can reasonably expect it, but it's not absolutely certain. Maybe the Encyclopedia Americana has different kinds of entries. Maybe the material is organized differently, and so there isn't an article on symbiosis, or the information on symbiosis is built into another article. But what counts here is that the argument is based on an analogy, which is a pattern of inductive reasoning. Look at number 13. World-renowned physicist Stephen Hawking says that the condition of the universe at the instant of the Big Bang was more highly ordered than it is today. In view of Hawking's stature in the scientific community, we should conclude that this description of the universe is correct. This is an argument from authority, so you're relying on what a prominent person, a prominent physicist said. That's the premise, and so you conclude reasonably that this description of the universe is correct. But as an argument from authority, this is an inductive argument. Also inductive is number 19. When the Romans occupied England, coal was burned. Since coal produces quite a bit of soot and sulfur dioxide, there must have been days almost 2,000 years ago when the air in the larger towns was badly polluted. So this is basically a causal inference. It's an argument that sort of reaches a conclusion from the fact that certain events were taking place that we may surmise that they, reasonably uh, uh, surmise that they caused a certain effect, but there isn't really an absolute certainty. Notice that the wording here isn't particularly significant. There must have been, I suppose you can take it in two different ways. Some of you may feel that this expresses certainty, that there must have been, that there had to be days, but must can also be used in a speculative way, as when you say, I see that the lights are on in the neighbor's house, they must be at home. When you say something like that, you're saying it's possible, it's probable that they are at home. So the wording here can go either way. This can be taken to express a strong conclusion following necessarily from the premises or a more tentative conclusion. So the wording doesn't help too much, but what helps here is the fact that if you think about it, the reasoning is causal. You know that when the Romans occupied England, coal was the main kind of fuel, and that coal produces soot, sulfur dioxide, so some form of pollution. So even 2,000 years ago, there must have been pollution in certain areas. But do we know this with absolute certainty? We probably wouldn't venture to say that. Finally, here's an example of deductive reasoning. And you can see that it doesn't really fall into any of the patterns that we talked about before, but it's pretty clear that this is a deductive argument because sort of the conclusion clearly follows with certainty from the premises. Eternity is simultaneously whole, but time has a before and after. Therefore, time and eternity are not the same thing. So this is really reasoning about identity. If two things are identical with each other, two things are the same thing, then they share all their properties, all their characteristics. But if you find that one thing, eternity, has a certain property, it's simultaneously whole, there's no before and after in eternity. And time, on the other hand, uh, has that property. So eternity doesn't have the property of having a before and after. Time has the property of having a before and after. So it follows with absolute certainty that time and eternity are not the same thing. Okay, it's as if you were comparing information that you have about two people whose name is John Smith, let's say, and you come to know that the first John Smith is married. The second John Smith is not married. Now you know that they're not the same person, even if because of the name you might have thought that they were. So whenever you discover a difference in properties between two things, that gives you the absolute certainty that they're not the same thing. And so in this case, the reasoning is deductive. I hope this helps, and I hope that will, if there are any questions, that